Okay, the homework questions from last night. So first, let's take a look at page 549. I asked you to do 13 and 14. So 13, a circus stunt person was launched as a human cannonball over a Ferris wheel. Isn't that the job you'd want to grow up to do? Okay, so they're being launched. It's going up. It's coming back down. Okay, and its initial speed is 24.8 meters per second. Sure, almost 90 kilometers per hour. Sign me up. Angle is 55 degrees. Here's a good question. Where should the safety net be positioned? So you're looking for the delta dx. And if the Ferris wheel was placed halfway between the launch position and the safety net, what is the maximum height? So, yeah, be good to know. How high can my Ferris wheel be so that you can clear it, over which the stunt person could travel? And then the third thing, how long is it in the air? And the fourth thing, how much are they paying you to do this? All right, so if we separate our givens, in the x direction we'll have VIX equals VI cos theta, which we can find. AX equals 0. And we're looking for delta dx and delta t. In the y direction, VIY is VI sine theta, and of course that's up. AY 9.81 meters per second squared, and that's down. It's really a 9. We are looking for delta dy max eventually, and of course delta t. So it's a ground to ground, and our trick for ground to ground is to look at just up. So if you look at just up and use AY is equal to VFY minus VIY over delta t, if it's just up, this will be TU, and this will be 0. And so we can solve for the time it takes to go up. So it'll be minus VIY, this guy, is VI sine theta, and it'll be over AY. So delta TU will equal negative 24.8 meters per second times the sine of 55 over negative 9.81 meters per second squared. And so we can find our TU. And if we do, you could get something like 2.07 seconds, but I think that's probably rounded. And then, of course, the full time will be 4.14 seconds. Okay, so we've actually solved part C already, but it's okay. That's just the book striking again. All right, so then the first question says, where should the safety net be positioned? So we're looking for delta dx, and it's just going to be VIX delta t, 1/2 AX delta t squared, and this is going to go to 0. So delta dx is going to equal VI, which was 24.8 meters per second, cos of 55. And you have to put the whole range in here. So 4.14 seconds. So delta dx equals 2 times 24.8 times the cos of 55. I think it's 58.914 meters. Okay? And then the B part, so this was A, this was C. And the B part, how high can the Ferris wheel be? In other words, delta dy max. VIY delta TU plus 1/2 AY delta TU squared. So delta dy max will equal a 24.8 meters per second sine of 55. And this time the 2.07 seconds goes in, plus 1/2 negative 9.81 meters per second squared, 2.07 seconds squared. Okay, so punch all this into your calculator. And I think the first term is something like 42.07 meters minus 21.035. And I think I've talked to you about the fact that when you do this, the second term will always be half the first term. And so when you subtract, you get 21.035. If you rounded your time a bit, it won't exactly be second. It won't exactly be half, but if you don't round, it should be right on. Okay, so that's number 13. All good? Number 14 is shooting a stone with a slingshot and hitting a target on the ground 14.6 meters away. So you start on the ground, and it ends back up on the ground, and delta dx is 14.6 meters. You give it a launch velocity of 12.5 meters per second, and neglecting friction, what must be the angle? So you're looking for theta, among other things. So in the x direction, Vix is Vi cos theta, Ax is 0, delta dx is 14.6 meters. In the y direction, Viy is Vi sine theta, Ay 9.81 meters per second squared. This one's up, this one's down. And so, again, ground to ground, we can start with looking at up. So at up, Ay is equal to Vfy minus Viy over delta Tu, and this goes to 0. So delta Tu will be equal to negative Vi sine theta over Ay. So delta T then would be equal to 2 times that. But I can't actually find what this is because I don't have theta. So I have to go to the x direction to get a second equation, because here I have 2 unknowns, delta t and theta. So I go over here, hoping to get the same 2 unknowns. The 1/2 ax delta t squared goes to 0. So this will be delta dx is equal to Vi cos theta. Delta t, I now have the same 2 unknowns, and I can take my delta t and fill it in. So delta dx will be equal to Vi cos theta brackets minus 2Vi sine theta over Ay. Okay, and so now I need to rearrange. I can bring my negative and my Ay over here. And Vi and Vi together will be Vi squared. And then I'll have 2 sine theta cos theta. So if I divide by the Vi squared, I'll be left on this side with 2 sine theta cos theta, which we saw yesterday in class. You have to use the trig identity. This will be sine 2 theta. And so we'll have sine 2 theta equals negative minus 9.81 meters per second squared. Delta dx is 14.6 meters. And this is 12.5 meters per second squared. And so you're going to get sine 2 theta to equal 0.9166. Okay, do inverse sine of both sides and get 2 theta to equal 66.44 degrees, which means theta will equal 33.22 degrees. So this is really theta 1. Remember we said yesterday that the second one is always 90 minus that. So it'll be 56.78 degrees will be theta 2. The textbook doesn't ask for 2, but in an assignment I would. The textbook goes on to ask what would be the maximum height and what would be the time of flight. So doing it for this one, once you have your theta, fill it back into this equation. So delta t will equal negative 2 Vi was 12.5 meters per second, sine of 33.22, and then divide it by negative 9.81 meters per second squared to get your time. And when you do that, I think you get a time of 1.3 396 seconds.